Hey, what's going on, guys? xiangqi here. In this video we'll write some logic to allow the computer to capture your group of stones if there is only one liberty left. But before we start, let me introduce a couple of updates I make to the code. So first we have this ePrint function definition, which all it does is simply allows to print a standard error buffer, and the reason for doing that, the reason to print to std error and not to std output, is because the Sabaki GUI doesn't show you whatever doesn't regards to the commands or the desired output, while the errors are being printed within the console nicely. So just to make our life easier and for the purposes of debugging, we may consider this printing to the error buffer. So yeah, this is kind of what we're supposed to be doing here. So for instance, just to distinguish which type of moves are we about to be considering doing there. So this is the first thing. And then since in the previous video we had here down below in the GDP protocol, the genMove function was actually calling the make random move, and this exact same site to move to parse from the command line. But now I've created the routine called genMove. It's currently empty, so here is the genMove and here is the AI logic from the previous demo video. So all it does, it just returns the random move, right? So that's pretty much all about it. So starting from now, we're going to be working here within this genMove function. So I also make some minor update to the print board routines just to fix the layout of the file names. So you can just download the code from GitHub and continue from this size, from this point, if you're interested exactly at the AI and not really caring much about the rules of game and the GDP protocol itself. So yeah, probably here we can say ePrint to print the std error, and here we just say random move. So just so that we know that we're doing the random move here. So if I just stop, detach, and Wally plays white and go, so like it just makes the move, but it tells us that this move is a random move. So in case if it would be considering some other moves, it would not be considering this move before. So it would just be I don't probably for now we can just consider returning before, just for debugging purposes. That's exactly, at least that's the way how I've been writing this. So we can just return when found a better move, and then when it would be the matter of having many moves, it's just it would be just easier to store those moves and then at the end take a decision on which we're supposed to be taking, and also not forget to check for legality, so to avoid the suicide moves. In case of the suicide moves, we're going to be calling random move. Anyway, so that's pretty much all about it. And now without further ado, let's actually start writing some code. So here is the logic to capture opponent's group of stones. So we just first need to loop over all of the board squares, so 4 square in range and the length of the board. Then we want to need the piece. Okay, so piece is equal to whatever available at board indexed by the square. And now we need to match opponent's group. So to do that, we can simply say if piece bitwise ended with 3 minus color, so opponent's group. In this case, we want to do the following thing. So we want to count liberties for opponent's group. Okay, so I just say count here and the current square, and the color is 3 minus color, so for our opponent. And then if if only one liberty left, so if only one liberty left, so I can say if the length of the liberties, is equal to 0, we know that this is the case. So we actually want to make the move whatever this square is. So whatever the square, so the square at liberties 0 is, that's the only move that would result in enclosing the opponent's group. So we can say that target square is equal to liberty 0, okay, and we want to, well, actually, yeah, for now, probably, I don't, yeah, probably let's just go for this. So just want to define the best move here is equal to 0, capture is equal to 0, save, defend. So these all are the move types, and surround also equals to 0. So in this case, what we actually do have is the capture. Yes, so the capture is equal to target square, and we also want to break from here, and then don't forget to restore the board. So restore board, okay, and also we need to assign the best move here as well. So I can say best move is equal to target square either. And here is the deal. So the best square would be overwritten during this different matches. But anyway, it's not going to be equal to 0. So if none of the logic of taking the moves is going to work, then we still could potentially have some best move there. And if we actually don't, only in that case we consider the random move. So maybe not the best ever implementation so far, but it kind of works just like I've shown you in the previous video. So I think that should be fairly enough. So what we do here, we just save the capture move, save the capture, save the capture move, right? And here, for instance, as far as this is the only one that is available currently, well, for now, well, let's just make it here probably. So let's say eprint, and this is gonna be the capture move. This is gonna be the capture move, and I want to return the coordinates of the best move, basically. Yeah, of the best move. Since it's the only one currently, so we don't have anything else. And this, the matter of storing this capture, save, and so on. So this will come clear later on when we're going to be considering some of those available best moves. So yeah, I hope that makes sense. But here we're going to be printing the this. So here just say capture move, and we can print this best move, the coordinates indexed by the best move. Okay, so at the moment, what our program should be capable of doing is to capture the group of your stones, if any. So I just detach this and Wally and play as white player. So we can continue the game. Excuse me, restore board's just a typo. Restore board. Okay, so let's start a new one. Okay, and play as white player. Something else, square, typo. One more time. Target square is equal to liberty 0. Oh, what have I done? I'm sorry. If liberty is equal exactly to 1, not to 0. I'm sorry, guys. Sorry for this inconvenience here. Obviously, if we have only 1 liberty left, so not 0, 1 liberty, that's important. So in this case, we can... okay, one more time. Oh, so he just tries to make the capture move by default. So let's say here we can say if best move. So so let's say found move, and only in this case, yeah, because otherwise, if there is no capture move, he would try to return best move, but that's equal to 0. Hence, it's indexed as XX. Like this coordinates for 9 by 9 or whatever. So yeah, actually takes this value in particular because it's 0. Okay, so now it in theory should be just fine. Sorry, it's going a little bit boring, but yeah, that's the way. Generate move. Oh, why do we play? So why player? And yeah, I forgot to make another important thing. We also need to make sure that we put the stone on board. Yeah, here we obviously need to set the stone. We're not testing for legality for now, so just set the best move and the color just to make sure that it gets synchronized with the board. So in this case, we have the capture move, and let's see. Okay, so random move so far. Just wait until it creates somewhere, until it creates a kind of surrounding somewhere so that it can capture. So this should happen one day. Okay. It takes a bit of a time with a random player. Yeah. We're going to start with surrounding first, but that just needs some extra logic to implement, so probably, yeah. It is going to take forever. I believe the better way of doing things is just to set a custom position here to give him a chance to find that capture move. So if I go to select stone tool, and let's just consider a group here, and now let's consider something like this, and now I want to play, so toggle edit mode. Okay, so now we should be in the play mode, so set as white player. And if I play somewhere, okay, failed to generate the move, name, but at least it tried. Okay, try to generate the capture. So name, target, square. Okay, another typo. Okay. And generate the move. And it does. Okay, so see, like it just did a capture move. And just to give you a bit more ideas, so if I put it here, then he captures because he can, right? So capture move. So if I play somewhere it just plays whatever, but not the capture move. But if I play here, then he just tries to capture. He's not trying to surround, but if I play into the tiger's mouth, you see like it just captures instantly. So this is the first thing to teach it to capture. So this was the random move, but the next one would be capture. And here we go. So you see like currently we've just taught our program to actually capture the stones. So yeah, let's keep things simple and let's separate the logic for different kinds, so sort of types of moves into the several videos. I don't want this to run forever. So the next thing we're going to implement is to teach the program to take the defensive action if his group is about to be surrounded. So in that case, just to make it avoid being captured by placing a stone to the only liberty left. So this is it from my side, guys. Thanks for watching. Until next time, and take care.